I've got a few story problems to do, taken from the book. The first one is a formula. They give you a formula, which is a big break. They give the story for the formula. P stands for the amount of carbon that a certain phytoplankton uses up. And I stands for light intensity measured in foot candles. So they give you the formula. And they just want you to find out for what light intensity is the carbon usage maximized. Well, that's a kind of interesting question. So, well, you just have to take the derivative and set it equal to 0. And since it's one of those fractional functions, a rational function, we use the quotient rule and focus on the numerator only. So you can see just doing the numerator only, there it is. So there's all the steps. It's not too bad. And then that numerator comes out to be just 400 minus 100i squared. Well, you know you're living right then. That's too clean. Now the intensity is measured in thousands of foot candles. So 2 sounds wimpy, but it stands for 2,000 foot candles. And I looked up what intensity you have for daylight. And daylight can be anything from 100 to 10,000 foot candles, depending on what time of day it is and whether you're at noon in Michigan or at noon in Florida or along the equator at noon. You know, there's a lot of differences in light intensity. So this 2 is actually 2,000. And it's quite a reasonable number for the situation. Then we put in the 2 into the formula for P, and we get this 20 milligrams of carbon per cubic meter per hour. So, and then P of -2, because if you see you got P, or you got I squared equals 4, so I is plus or minus 2, but you can't have light intensity of -2,000 foot candles. You know, 0 is dark. So you don't have negative foot candles. You don't get owed light. So anyway, that's that problem. That isn't too bad. And now one more for you. Hang on, I gotta get the weasel. Come here, you. All right, go ahead. And here's the other problem. So we got a box that's open on the top, and we're going to try and make this box to minimize the material. So you see the costs. And now we got to lay down this this problem. Let's see what we can do. Well, first thing we notice is the story didn't tell us the height of the box, but it's an open box, and it's got to have a height. So there's that. So we got to write a cost function. Well, let's see what we got here. So cost comes from surface area, and so we're going to have the base plus the sides. And then if we multiply by the dollars per square meter, we should be able to get a cost function here. So I'm going to write cost equals. Let's see if this works. So the base is length times width, and it's times 10. So it's 10 LW. That's cost for the base. Now we got the sides. Well, there's 2 W times H sides and 2 L times H sides. But those have the same cost because they're the sides. You know, they're the sides of the box. So we have that. So I'm just going to put 6 for the cost, and then I'm going to have 2 WH's plus 2 LH's. Well, we've got 3 variables, L, W, and H. We got to do some substitutions. We have one right away. L equals 2W is a really fast and easy substitution to do. So we can, that means I'm going to have, in my variables, I'm going to have some W's, and then the L's are going to be replaced by 2 W's. So if I could just come up with a way to rewrite H in terms of W, I'd be all set. Well, anybody watching at home should be noticing that we've never used this volume to be 10 cubic meters thing yet. And volume, remember, is equal to length times width times height. So let's start getting our substitutions ready. I have L equals 2W. That's good. What about 10 equals 2W times the L times the W, which was there, and then the H, which means that H is equal to, you can solve this for H, and that's going to be 10 divided by 2 divided by W squared. So it's going to be 5 over W squared. That's not too bad. Oh, geez, stupid weasel. Get out of the way. Go on. We're trying to do calculus. Oh, God, I just stepped on the keyboard. Is it still going? Yeah, it's still going. Good. So I've got H equals 5 over W squared. So that means I can rewrite this formula down here. 10, L is 2W, so that's a 2W, and another W that was already there. This is a 6 times 2, that's a 12. The W is still W, and the H is 5 over W squared. Hang on, stupid weasel, stepping on my keyboard. And then you have 6 times 2 again, so it's another 12. And this time it's L, which is worth a 2W, and then the H, which is 5 over W squared. So let's get that all on screen there. Sorry, I got some, I'm giving CocoaBananas a drink, and she's slinging it around. She got a little drop on the paper. It made the ink run. Hey, Coco, get over here. Hey, hey, hey. No, don't. God, weasel. This weasel's trying to kill itself. Coco, get over here. Get over here, you weasel. All right. I'm trying to make a film star out of her. All right, well, you can see what to do. I'm going to get 20W squared. I'm going to get a 5 times 12 is 60 over W. And then I've got a 2 times 12 times 5. That's a 120 over W. So 60 plus 120 is 180 over W. And then I have that 20W squared, and that's equal to cost. Well, we're supposed to minimize cost. Oops, there's a plus sign between them. Oh, God, get over here. So all that's left is take the derivative. So the derivative of cost with respect to W is going to be 40W plus, remember this is like 180 times W to the negative 1. So it's actually going to be negative 180 W to the negative 2. And we set that equal to 0 and solve for W. So 40W minus 180 over W squared is equal to 0, which means you have 40W equals 180 over W squared. Cross multiply. 40W cubed equals 180, so W cubed equals 180 over 40, otherwise known as 9/2. Let me get that on the screen there. So that's W cubed equals 9/2. So that means W is equal to the cube root of 9/2. You can keep that around, or you can pop it using a calculator into the cost equation. I popped because the problem was find the minimum cost. So the cost is going to be approximately, I used the decimal approximation because it's going to be dollars. Dollars only has 2 decimal places. So I got the decimal approximation of the cube root of 9/2, plugged it in for every occurrence of W right there, and I got about $163. So that was minimum cost. That's the minimum cost for this box. Well, that's 2 story problems for you, and now I have to go catch a weasel. See you in class.